So we got the pocket milling operation done. First we have did the face milling operation, then the pocket milling operation. Let's get towards the drilling operation. So the drilling operation is very simple. You have to create holes. Drilling is called creating a new holes into your workpiece, and for that drilling operation consists of further operation which is called the center drill. So you have to mark center before performing the drilling operation. So for that purpose, what we're going to do is we have to select all these circles, and then we'll create the drilling operation. So for that purpose, go to toolpaths and select the drilling operation and select your holes. Okay, so I'm going to select according to the path which I need. Like I want to create it this way, okay, in a zigzag way. So I will select in a zigzag way. Okay, this. It will automatically select the center point. Okay, you don't need to worry. So I have selected the points. It has already selected the diameter is 5 millimeter, all we have. Okay. And just click OK. Now what we need is I want to perform a drilling operation, but instead of drilling operation, I just need to do a center drill operation. So center drill and drilling is both operation. For both operations, you have to select the drill operation. Okay. But what you need is you need to select a center drill for this operation. Okay. So go to filters and select none, and here you have to select a center drill. So this is what we call the center drill. We have to mark center, and this operation is very helpful for performing the drilling operation, because it will guide the drill to mark at the center of hole. Okay, so if you don't perform this center drill operation, your hole will be out of the center. Okay, so you need to have center drill operation first and then the drilling operation. So I have selected the filter and need to apply a center drill tool. So it never shows the any tool here. So don't worry about the center drill. Just what you need is to let me check once again. So there is no center drill tool here. Okay, so just need to create a tool and center drill for hole making. Click next and give some size. For example, we are going to perform center drill for 5 millimeter diameter. So what I'm going to do is I'm going to select this size from this 5 millimeter, and it will create the tool according to this. Finish. So it is third number tool, and it's a center drill, and its tool diameter, overall tool diameter is 12.5, but it has a 5 millimeter tool. Okay, and mark the speed of 1000 RPM, and the feed rate is 100 millimeter. The feed rate for the cutting tool, for drilling operation, for center drill, for framing is different, because your cutting rate and feed rate is converted into plunge rate. Okay, so plunge rate is equal to your feed rate. So therefore you need to set the cutting feed rate by calculating it, and according to your workpiece type and cutting tool type and the machine quality. Okay, we don't need to worry about that. So for that, let me define the diameter of the tool. Double click just to show that we have the correct size. So the drill diameter is 5 millimeter. Overall length is this. In the shank diameter is 12. Okay. So I was little confused about the tool diameter, which is 12.5. I have to use the 5 millimeter. So that's okay. I've just confirmed it. So tool holder is okay by default. What about the cutting parameters? So we have a different cycles over here. We will have the drilling, contour, boring, and we have the packer, drilling operation, chip breaking, tapping, boring, fine bore, rigid tapping cycles. So we have a lot of cycles here, and you can customize your cycle. We have a slot from 9 to 20 slots available to create a custom drilling cycle. But what I'm going to do is I'm going to perform a contour bore or drill option. Just I have to mark a little center at these holes to guide our tool, our next tool, which is a drilling operation. Okay. So what about the tool axis? We have 3 limits. No need to create whole segments and limits. Just give a limit, the linking parameters, and set the reset point is 2 millimeter. Make it 5 millimeter. Sorry. Okay, we'll make it default 10 millimeter. And how about the top of the stroke is 0.0, and how about the depth of the center drill? So just need to set the minus 2.5 millimeter, because 1 millimeter is already removed from the surface using the facing operation. So we got last 2.5 millimeter. So from 1 millimeter, if we remove, we have already back 1.5 millimeter depth of the center drill. Okay. And about the tip compensation, we don't need arcs, planes, coolant. So for the center drill operation, we don't need any coolant, because it's just a little amount of material we have need to remove from the surface. Just we need to create a little point to guide the drill operation. So just click OK, and it will definitely create a tool path according to your tools you have, according to the circles you have selected, or according to your geometry you have selected. Okay, so I just selected the geometry in a zigzag way, so therefore it uses a zigzag method to perform a center drill operation. Okay, so let me show you. Click back plot selected, and here we go. This point. Okay, just create a simple center, and this is how we can perform 2D operations. 2D operations are very simple to create, and will help you to create simple geometries and simple operations to perform on your geometry, and these are not difficult operations. So the other operation, after performing the center drill operation, you need to perform a drilling operation. Okay, for that you just go to drilling operation and select again all these geometries. Okay, so this time what I'm going to do is I'm going to drill in a different way, like this, and again this. So first we did the horizontal way, selected zigzag. Now this time I selected in a vertical way to perform zigzag operation. So this is just to show you that we can do in a different way. So it's nothing difficult. It's a very simple, just drilling operation. Now this time we need to select a drill tool, and this time the tool will be 4 tool. Sorry, go to filters and select drill. So here we have the drill. Okay, go to library and you have to select 5.0 solid carbide tool. Okay, click OK. Have an RPM of 1800 and the feed rate of 150 millimeter, and the tool number is fourth tool. Okay, so we're using the fourth tool for this operation, and go to cutting parameters. So this time we are not going to use drilling and contour bore method, because it will go straight down in a single step and perform the operation. And if you have a hard material, it will break down and the cutter will be damaged, and it will also damage your workpiece. So for that you need to have select the pack drill operation. It will take a little packs to and get down into your workpiece and make a hole. So I want to take a pack of 0.5 millimeter average time to create a hole. Okay, so I have selected 0.5 millimeter pack, and it will take like this: 0.5 millimeter, then up, then 0.5, then up, then 0.5, then up, 0.5, and then up. It will work like that. So go to tools, axis and control. We have already selected the 3 axis. Limits, we don't need any limits, because for these things are used in the when you are performing the multi-axis. Okay, whole segments, you don't need any whole segment section. Linking parameters will define the depth of the hole. So right now I'm going to select minus 20 millimeter depth. So it will go to minus 20 millimeter in the depth and create a hole. But in minus 20 millimeter, it will take 0.5 millimeter every step to create hole. Okay. So this time I'm going to select coolant on, because we need a lot of coolant to cool down the tool, because drill is a very sensitive tool. When it breaks down easily. So for that, you need to have a lot of coolant while performing the pack drilling operation. So let me show you how it looks like. Okay. So let me slow down. Yeah, and this looks like this. This looks like this. So it's taking 0.5 millimeter every time to perform the operation. Okay. And this operation has to break down the chip. Okay. And you can select another option, which is also called the chip breaking. Go to cutting tool parameters and you can select chip break method. It will never go at high, but it will take 0.5 millimeter pack constantly and move the material. So let me show you how it looks like. This. So it's getting down, and you see that it will take 0.5 millimeter up and down in a constant way and remove the material, but never goes high above and do this perform. So this is what we call the chip break cycle, which is also a canned cycle here. Okay, and now it will go to another hole and perform the operation. So the last operation was pack drilling, which is in terms of G code, we call it G83 cycle, which is also called the G83 pack drilling canned cycle. Okay, so it will follows according to your hole selection and create multiple holes according to geometry you will select. If you have a different dia holes, you can just create a different tool and select the tools and create according to, you have to just follow the same process for different size of holes you have. Okay, so I'm just giving you an idea how we can create hole operations or drilling operation. Okay, so we did the facing operation first, then pocket milling operation to perform pocket, then the center drilling operation to mark center, and after that center drilling operation, we did the drilling operation. So make sure that you have to perform first center drilling operation, then the drilling operation. Okay, let me hide this operation. Let's go towards the slot milling operation. We need to create a slot. Okay, so check here that we have a slot or not. So here we have the slot milling operation. So efficient machine around slot. The slot must be closed and include two parallel straight sides. Okay, so what we have an open side. What to say that? So let me select single line. I don't want to select chain. If I am going to select chain, it will select all these lines. So what I want to perform the operation on this side. So I'm going to select a single line. Click this, and this. So this is what I want to do slot operation over here. Okay. Click OK. And select the tool. We have a tool. We want to use an 8mm and mill. So this tool we're going to use that and define the RPM is 6000, makes feed rate 1500, and the plunge rate is 300 mm. And the cutting parameter is according to the compensation type. It will automatically select the compensation, and about the exit and swipe is 180 dt. And don't want to leave the material from the wall on the walls and along the floor. I will just make it 100% accurate according to my size I need. So it will take a frame pantry at an angle of 3 degrees, and it will take a roofing operation with the 50% or step over. That's okay. How about the finishing operation? Just take a 1mm finishing operation for the finish pass. Okay, keep tool down. It will take the tool down. It will then go back to every track point and then take another step to perform the operation. But it will always make the tool down, and after completion, then it will go back to its retract point. How about the depth of cut? I just want to make the step of depth is 0.5 millimeter. And here also I'm going to select keep tool down. Okay. And how about the linking parameter? Retract point is 25, V-plane is 2.0 millimeter. And how about the depth of the slot? And just need to make it depth 10 millimeter in negative direction. So we need a coolant for this operation. Okay. So as you see that the at least one boundary slot width adjust for the stock to leave on wall and finish passes as smaller than the tool diameter. Please choose smaller tool. Use a smaller or negative stock to leave on wall if you're finishing passes. So just give few passes or leave some stock on the wall. It says that you need some wall on the stock on the walls. Okay, gives 1 millimeter on the wall. So at least one boundary slot width adjust for the stock to leave and wall finishing passes. And please choose a smaller tool. Use a smaller negatives stock to leave on wall. Fewer finish passes. Toolpath generate failed. Okay, so let's define some stock on this side also. And this time again it gives an error. And let's delete this. And what we're going to do is let's perform this operation by using a 15 millimeter tool, or what we can say that you can use a smaller tool to perform this operation. Okay, go to milling and slot milling operation, and select the single tool path method, and go to tools and select tool which is in smaller diameter. Let me define a flat and mill with a diameter of let me make a diameter of 4 millimeter, and this time the tool is it's this tool we are using, and the spindle speed is 6000 rpm, feed rate of 1500 millimeter, and the plunge rate is 300 millimeter. Okay, and make all these by default setting, roughing by default depth of cut 0.5, and linking parameter make it absolute to -10 millimeter. Feed plane is 2 millimeter. That's okay. Click OK. So at least one boundary slot width adjust for stop to leave on wall and finish process is smaller than the tool diameter. So it says that the finish process is smaller than the tool diameter. Please choose a small tool. Use a smaller or negative stop on the wall when or finished passes. Okay. Let me check if there is any rough and finish operation. No. Spacing is 0. Let me is 0 millimeter. And how about the step over is 2 millimeter. Okay. Okay, so this time we got at least one boundary slot, got a similar error over here. So delete this, go to this area, let me select slot here. To give the height 8.0 and the width is 80 millimeter. Okay, and let me apply the slot milling operation on this side, so we'll get the results. Toolpaths, slot, we'll select the chain option. Okay, got a tool of 4 millimeter, and all these steps by default give the depth of cut 0.5, keep to down, and -10. Okay, so I also that the error comes because of the open boundary. So we have the closed boundary here. So this error goes because of the closed boundary. So this boundary is open, therefore it gives an error. Let me close this boundary and check whether the error still here or not. So I'm going to select a geometry. I'm going to select another tool path. Go to tool path, slot, and select this, and this. Okay. And slot operation tool, we have the okay, let me define the 8 millimeter tool with the RPM of 6000, and plunge rate is 300, feed rate is 1500. Cutting parameters, we don't want to save any material, not exact amount, and the finish pass is okay. Step over is 50 millimeter. How about the depth of cut? 1.0. Keep tool down. Linking parameters, make it to -10 millimeter down, and the feed plane is 2.0 millimeter. And this time we need to have a coolant on. Click OK. So here the same error occurs. Let me give this cutting parameters 1 millimeter stock on the wall and 1 millimeter on the floor for the finishing operation. So this time again the error comes, so our geometry is not fully okay. So this geometry is okay. So we'll get this in terms. We're going to delete this by right click and delete this slot operation. Okay. So let me delete this line. Yes. Yes. This line. Yes. There's this line. Yes. On this line also. Let me join this entity. Okay. So we have to join the entities here. So all these are selected. Click join entities to join. Yes. Okay. Okay. So we got the entities joined. And how about the finishing operation, facing tool? He says that the facing operation is down because the entities has been changed. So you just need to rechange the geometry. Click OK and refresh it. It will automatically select the geometry. So from all these, we have done the facing operation, pocket operations, center drain operation, then drilling, and then the slot milling operation. Now this time we have to perform the contour operation. So contour operation actually perform to remove the material from the outside of the boundary or inside of the boundary. And just to remove the material from the profile of the, we can say that it is a profile milling operation. And in this operation, it will just remove the material of the boundaries, okay? Not just from, just like in a pocket milling operation, it will not remove the material from the whole surface area, but it will just remove the material from the circumference or the path which you have selected, whether to be make inside or in the outside. Let me show you. Go to milling toolpaths, select the contour operation and select the chair. So just want to remove the material outside this boundary. We're going to select this operation afterward, or whether to move the material inside or outside. So select the tool. I'm going to select the 8mm tool, make the RPM 6000mm and the feed rate of 1500mm. Plunge rate is 300mm and tap type. So this time there we have the compensation type. We want to move the material on the left side or the right side. It will decide by the computer, okay? So most of the time it will decide by the computer. If anything wrongs, then we can change the direction, okay? So just make sure that you have selected the compensation type by the computer. So how about the contour type? We need to perform in a ramp direction. We don't want to remove material in the 2D direction. We want to remove material in ramp type. We can helically move and remove the material. So how about the angle of ramp is 3 degrees, sorry. So if you want to move material by depth, then you have to give a ramp depth. So for the smooth operation, let's define 1.0mm depth of cut. So stock leaves on the wall is 0, it's 0 on the floor. For the ramp cutting, you don't need to set the depth cuts. Okay, so this option will be definitely down or inactive. Let's go to lead in and lead outs. You just need to select the lead in and lead out. How the cutting tool will be entered into your workpiece. So that's okay. Breakthrough, multi-passes, running multi-passes, and just define the block size. So we have a block. So this is what we call the block and actual part we need. And what we want is to remove this part. and we want to get this part in actual size. So here you have to set the feed 2.0 millimeter, top of the stock is 0, and the depth is minus, let define it to 35 millimeter minus depth. Set the coolant on. Okay, so this is how the contour tool path works. I said that the contour tool operation is always works on the boundaries. Okay, it will never move the material inside, just like pocket operation. Okay, so it will never move the materials just like a pocket. It just move the material outside the boundary or inside the boundary. Let me show you if you select the inside boundary. Go to geometry, click, right click this and change the side. So you see that inside work and refresh it. So it will move the material inside, not the whole material, just follows the toolpath. So make sure that you have to select appropriate side to remove the material. Change the side to the outside direction, click OK and refresh it. So this is how the contour operation works. Let me show you how it looks like. So most of the time we use the contour operation to perform simple cutting strategies, okay? Simple parts. So you see that enters in a tangentially way and it will perform all the operation. After that, it will go back tangentially exit and tangentially exit from the path. Retect goes towards the retect point. How it looks like. Okay, so we have almost done all the 2D toolpaths mostly used in 2D toolpath strategies. We did the facing, pocket, center rail, drilling, slot milling, and contour operation. And these are the almost to mostly used toolpaths in any type of geometry, whether in the 2D or in the 3D operations. Mostly use all these toolpaths. So one operation we have left, which is the chamfer. So the chamfer operation is all about to give edges to remove sharp edges. So for that operation, you just need to make this boundary solid. Only need to make this object solid. So for that purpose, go to solid, and I want to create this block, solid block. Okay, so just need to create a solid object for the model, chamfer model operation, which is the last toolpath we need to discuss in this lecture. Select the extrude, and I'm going to select this chain because I want to create a solid block. Click OK. So it creates a block in upward direction. I just want to make it in the downward direction, okay, like that. So it create a block in the downward direction. I want the Z direction 0 and in the downward direction it's a 50 millimeter. Okay, that's okay. Click OK. So it just create a solid block. Let me show you. So this is what it looks like. Okay. So now I want to create a chamfer, or I want to remove the sharp edges which has been created during the contour operation. Okay. So during the contour operation creates a sharp edges. So I hope so that it just takes the 35 millimeter and make it 15 millimeter. So just I want to edit the setting, go to solids and extrude and make it 35. Okay, not 50 millimeter. Just give 40. It's also okay. Okay. So we got a 40 millimeter. Need to regenerate the solid. Okay, we got. Now the next operation, we just need to remove the sharp edges and make it chamfer at an angle of 45 degree. And for that, you just go to toolpaths and select model chamfer. Okay, so this is chamfer drill, And here we have the model chamfer. Okay, after the slot milling operation, click OK. And model chamfer we have. Select the geometry you need to chamfer. So I just want to have chamfer on this face, or you can say that I want to have chamfer on all these 4 edges. Okay, so in 3D object you just need to select 3D. So this is 3D block. We have selection method. We have filtered these edges and face. Okay, click OK. Now select the tool. So for that purpose you need a tool for the model chamfer. So go to filters, select none, and here you need to select radius mill. No, we need a chamfer mill. Yes, we can select a chamfer mill. We need to create a chamfer. And here what we have the counter saying no, we need a chamfer mill. Click OK. And go to library, and we have the chamfer mill at an angle of 90 degree. 10 millimeter is the diameter, 4 fluted. We have the 412 millimeter dia and 90 degree, and 16 millimeter dia with 90 degree. Okay, so I just select the 10 millimeter by default with the 4 fluted. Okay. And how about the RPM? Make RPM 6000, and the feed rate is 840. Let make it 850 millimeter, and the plunge rate is 300 millimeter. So give this tool tool number 6 or 5. I hope so. It's a 5 number tool. So we can change it. Let us see here in the 4 millimeter. Okay. So 1, 2, 3, 4, and 5, and that's 6. Okay, it's a 6 number tool. Okay. Now go to cutting parameters. So we have the cutting parameters and we want compensation to automatically sent by the computer. Okay, we don't want any manual compensation. You can select it by click on this and give compensation manually. We want it to select it by the computer because we're using the 10 millimeter dia chamfer tool. It automatically select the how much we have to far away from the workpiece. Okay, what about the chamfer width? So how much width you want to remove or give remove from the material from the edge? So if you're going to select 1 millimeter, it will give a 1 millimeter in from the in x-axis and 1 millimeter from the down size to give an 45 degree chamfer. Okay, so the purpose of chamfer, giving a chamfer operation, is to just remove the burrs or remove the sharp edges. That's it. So 1 millimeter is enough. If you want to perform it more, you just have to select 2 millimeter or any model size, any geometry gives you that you need to perform 2 millimeter chamfer. Then you have to perform the model chamfer in a step way. Okay. You just not give the chamfer 2 millimeter in a single step. You just need to perform the chamfer in a multiple way. Like first you have to perform 0.5, then 1 millimeter, then 1.5, and then 2 millimeter. So because chamfer tool is a very delicate tool, it has edges, and its edges will be damaged when you give high amount of chamfer. Okay, I just give a 1 millimeter chamfer. How about the depth? Just give you depth of 0.5 inches. Definitely it will take 2 steps to perform. How about the lead in? Just take a lead in at an angle of 90 degree, and multi-passes, don't need any multi-passes. Clearest feed plane is 2 millimeter. Okay. Click OK. So it takes 2 steps to create model chamfer. So right now, what I'm going to do is I'm going to show you how it would looks like. So first thing, let me hide this toolpath and show you. So this is how it will perform and create chamfer around the edges. So now I will perform all these operations in a 3D way and show you how it looks like. So go to select all the operations. I have selected all the operations. Show them and go to machine and verify it. Okay. So we have selected the verification. It will process the NC data, and another window is opened. And here you will get the 3D view of machining. Okay. So let's make it slow to show you how it can look like. Very fast. So you see that the first thing we have the very fast face milling operation. Then we have very fast pocket milling operation. You see that around corners, you have round corners here because of the tool which we use. We have 8mm end mill and 4mm radius is not being removed. It give 4mm radius at the edges. Okay. So this is how the machining operation will be performed and how it takes out. Okay. So this time it's performing the drilling operation. And now the slot milling operation. It's simple slot milling operation. So that's okay. So now it's performing the contour milling operation. You see that it's just remove the material and give a value to block. Okay, the actual block we need after performing all the operations. We definitely remove the material and give you the insect size. It could just go down to -35. It's just 30 and we have one new cloud. So just give and the chamfer at an angle of, see over here that we have a chamfer at an angle of, so we don't get a chamfer here because we don't define the feed plane. Okay, for that purpose just close and exit and go to model chamfer and give feed plane to -1 milliliter. Okay, it says that it never 2.0 and 2.0. Give it 2.0 because 1mm is already down. Okay, just verify it. Let me just verify it by simply drag this tool into workpiece. Okay. Okay, just I'm going to show you that how it would look like. Okay. So it will just give you an idea how the chamfer is or chamfer operation is being performed. So it will give a chamfer like this, okay? To take 4 steps to perform this operation, because I just give 2 millimeter. Because 1 millimeter is already being removed during the facing operation, and I just enter the 1 millimeter value. So therefore, it never cuts the material from the upper face. So I just give 2 millimeter, and we have the chamfer right here. So this is how we can perform 2D operations. I have discussed it step by step. So we discussed the facing operation first, then the pocket milling operation, then we perform the drilling operation, and before drilling operation we perform the center drilling operation, then drilling operation, then slot milling operation, and at the last we perform the model chamfer tool path. So I hope these lectures help you to perform 2D operation, and stay tuned for further information. Thank you very much.